Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth. Hey, Physics with Beth and Beth. Welcome back. We're on AP Physics 1, Unit 5, Torque and Rotational Dynamics. We are now, I think this will be our last video, maybe last video for this unit. We do plan to do videos for all units 6, 7, and 8, all the way till the end, even the new unit with fluids that's new this year. So, but the last one for this unit, we think. But anyway, so let's talk about torque and power. We have not related that yet. So far, we've talked about torque. We've done lots of problems with torque. We've talked about rotational dynamics and those static equilibrium problems. So now we're going to talk about power. All right, well, if you remember in our previous unit, when we talked about power, we said power was equal to work over time. All right, and then work was force times the parallel force times displacement, and parallel force to displacement, and then times displacement, if that makes sense. It looked like this: parallel force times displacement over time. It also could be changed in that kinetic energy over time, all sorts of things. That was linear. Now we're going to talk about this rotational. All right, and in the rotational, power is equal to, and it's going to be a capital P, by the way, that's going to be the symbol. It's still going to be in watts. Just like power was a capital P and the unit was watts, that's not changing at all for us. But now when we're talking about rotational, we have a rotational piece. So power is going to equal the torque times the angular velocity, or also called rotational velocity. You'll hear it both ways. Okay, so that's the formula. That's all you got to know. So we're going to just get started with this problem. Hopefully it's a little shorter video today. A motor with a torque of 40 Newton meters. So there's our torque. So we know torque is equal to 40 Newton meters, Newton times meters, I should say. And then rotating at a constant 120 RPMs. They want to calculate the power output of this motor. Okay, RPMs. That is actually angular velocity, right? 120 RPMs. That's revolutions per minute. But remember, we cannot have revolutions per minute. We need it in radians per second. So we're going to remember from the very beginning of these videos that we started in this unit that one revolution, and let me write it up here, one revolution is equal to 2 pi radians. And we abbreviate that as rad because rotational motion is rad. All right, but don't abbreviate it as an R, because we have radius in these formulas. You will see as you've gone through this video, so you don't want to confuse yourself. So one revolution is equal to 2 pi radians, which is also actually equal to 360 degrees, right? One time around the axis there. So I'm in revolutions. I'm going to put what I want on top. I'm going to go ahead and erase this. So I want 2 pi radians on top, because I need, where I'm going from revolutions per minute to radians per second. That's where I need to go. All right, so and that's equal to 1 revolution, right? 1 revolution is equal to 2 pi radians. So why did I put 2 pi radians on top? Because the unit that I want, I put on the top, and then that makes my revelations. Hopefully this problem is a revelation, but anyway, the revolutions cancel out. All right, now I have a minute, so I want my minutes to cancel out, and I want seconds in the denominator. So 1 minute is equal to 60 seconds. I want those seconds in the denominator just like I wanted radians in the numerator. So now look, my minutes cancel out, and I'm left with radians per second. So, yay, we've done that right when you get the right units that work out like that. And if you take 120 times 2 times pi and then divide by 60, multiply the top floor, divide by the bottom floor, you get 12.57 radians per second. All right, so now I know the real number that I need to put in this formula, and I know my torque. So now, easy peasy, it's plug and chug. All right, torque is 40. My angular velocity, we said, was 12.57, and that is radians per second. That is a Newton times a meter. And here we go, so that is power. And our power, if you multiply those together, you are going to get 502.7 watts. Or you could have said 503 watts. And that is how you do power with rotational motion. All right, perfect. Hope that helps. And by the way, that Newton times a meter divided by a second is actually a kilogram times a meter squared divided by a second cubed in SI units. So that's saying the same thing, that Newton times meter times radian, which radian is really a placeholder, divided by second. So that is a watt. So that's why we can say watts, because Newton times a meter divided by a second is actually a watt. Okay, perfect. I hope that helps. Hey, if you like this video, please give us a thumbs up. If you want to subscribe, we would love that if you subscribed. We have lots more videos coming up, like we said, for Unit 6, 7, and 8 that's coming at you pretty soon. And thank you for watching, and happy physicsing.